Hello everyone. Today we'll be solving Leetcode 236. Okay, let's check this out. Given a binary tree, find the lowest common ancestor of the two given nodes. Let's reset this. When was the last submission? April. Okay. Find the lowest common ancestor of two given nodes. According to uh, let's 5 and 1. 5, 1, and the lowest common ancestor should be 3. Right. Okay. Hmm. So we're given two nodes and and we need to return the parent node. Can What is the other example? 5 and 4. 5 and 4. The answer would be 5. Right. Hmm. Okay. So what we can do is we can perform a normal DFS having the node, and while returning we return true or false if the two nodes are there. So if both P and Q are under this node, then we return true. I think that is the right approach. But how do we know which is the least common ancestor? Okay, the first one to return that should be the right answer. Okay, right. Hmm. So, if let's have like something called count is equal to 0 initially. Okay, so if not node return, if node dot val, hmm, does this work? Let's say we have 351, 351, 6208, 6208, and 74. Okay, so we come here, increase the count by 1. Okay, that's not how we do it. we have to call the function first and then increase it. So we call uh, t if node dot right, tf plus of right, and if node dot left, tf plus of left, and then we increase the count by one. And if the count is equal to 2, then we return what do we return? Return no dot val. So the answer is no dot val. We do have a problem. Let's say we come to 5 and the count becomes 2. Yeah, we're changing it again. The result R1, 2, and then if R1 greater than um, wait a second. Let's just say this is 0 and then this is 1. If R1 or R2 return 1. The problem is we need the node as well. We need the node. Okay, let's call the function and return. So return result TFS of root. And we also need P or Q. Right is not defined. TFS of okay. Let's do one thing. Uh, if TFS of node dot right or TFS of node dot left, okay, then we return one. P dot val. What is this? Oh, I need to return the tree node itself. Right. Okay. Then the result is equal to the node itself. Okay. First of all, let's print node dot value. Are there unique numbers? Okay. They're not unique numbers. Let's look at the constructs. Okay, all noted. Yeah, they are unique numbers. Right, right, right. I think I, yeah, let's say we have one here and then, hmm. So if node dot val, there shouldn't be a global. Okay, let's pass and count. Wait a minute. Gotten a bit rusty. Let's say we have this tree here. Okay. So suppose we call the DFS on this, and let's say the target is 5 and 4. This will return. Okay, I need a plan. Yeah. So this should return 1, 0, 0, 1, and here it becomes 2. So the first time when it's 2, then we set the result as that. Right. Okay, right. So here, I think it's simple. So let's say if not node return 0. Okay. Okay. If node dot val is equal to p dot val or q dot val, then wait, let's say our result count is equal to dfs of count, right? Yes, dfs left. If count is equal to 2, and set result is equal to no. Then 0 if return count. Yeah. And then we return result, non-local result. Then we call the function also dfs of true. Yeah, Arvind, Are we not supposed to include the current node? Are we, okay, wait. 5, 5 and 1. That is correct. The second one is 5 and 4 is 5 itself. What am I returning? 3. Okay. If count is equal to 2, return 0. Let's print. Yeah. We also need the node, right? So node is equal to node. Okay, node 3. Why is the count increasing like that? If node dot val is equal to q dot val or p dot val. Okay, or node dot val is equal. Yeah, I made a mistake. Yeah, that should be fine. Yeah, so that was the solution. Thank you for watching.